Hello, everyone. I'm going to present the paper entitled as Explainable AI for Epileptic Seizure Prediction, a Shape and Line Approach. Here are the authors of this paper, and I am Shohak Kumar Mondal, who is presenting this paper. Here are the outlines of the entire presentation slide. So, what is epileptic seizure? It is a sudden uncontrolled electric disturbance in the brain, causing changes in behavior and movement or consciousness. So, over the world, it is almost 65 million cases globally, and in each year, there are 5 million new cases. So, seizure is very dangerous. It can lead to accidents and injuries, and 30% of the patients are drug resistant. So, and in figure one on the right side, we can see that one person is in epileptic seizure stage, and this person has lost his control over his body. So it's definitely very dangerous. EEG, a primary tool for diagnosis and monitoring epilepsy, and analyzing EEG data for seizure prediction using various classification model like random forest, extra T gradient boosting machine. We can classify the epileptic seizure from a healthy subject. And shape and line can be used to explain the machine learning models. Here the related works where Shoaib and others, which is cited as three, these authors used FFT and SVM, and in their EEG signal, they extracted the features, the signal range which is lies in 0.5 to 25 hertz. And this author focuses on seizure detection. And Rakesh and others applied MSPC model, and as a feature they used a temporal based feature, and they show 88.89% sensitivity and low false positive in their paper. Liu and other use multi-view CNN framework, and as a feature they use time and frequency domain features. And also they in this paper they needed a broader data set for validation, because we noticed that it is a limitation of their paper. They use a very narrow data set to evaluate the model properly. And the paper cited as six, the authors use DenseNet, and as a feature, as a data, they use 1 second EEG signal sample, and they claim 94% accuracy. And in the paper cited as 7, the author used semi-deliant CNN, and as a feature, they use scaleogram via continuous wavelet transform, and they claim a very high sensitivity, 98.9%. So here are the objectives of our research. So there are total 4 objectives. The first one is pre-process and analyze the epileptic seizure data to improve the data quality and balance the class distribution. And the second one is develop a seizure prediction system using different machine learning models. And another notable objectives is evaluate the performance of multi-class classification for seizure prediction. And the last one is implement explainable AI to interrupt the seizure prediction models decision-making process. Here's the methodology. And first of all, I'm going to discuss about the data set on which we perform this study. And the dataset name is Epileptic Seizure Recognition, ESR, and we taken this dataset in UCL repository, from UCL repository. There are total 500 unique EEG recording and is representing one patient. And the final dataset is 11,500 item with 178 explanatory variable. And there are 2 categories. One is seizure activity, and another one is non-epileptic seizure activity, which is marked as 1 and 0. And here our proposed block diagram for this research work. First of all, this data set is fitted in a pre-processing module. Here inside the pre-processing module, we can see that there are four steps. The first one is data cleaning, random oversampling, outlier rejection, and merging ES class, epileptic seizure class. And then the clean data, the pre-processed data are fed into a data splitting technique. We split a data set into training and testing sets. And finally, we feed our splitted data into a different machine learning model. And then we test our model and evaluate the result. And we selected our best model. And using explainable AI, we explain the model, how it works, and which features are responsible for this classification task. So here the data pre-processing technique we already mentioned. We use outlier rejection, random oversampling, and merging epileptic seizure class. The replaced we for outlier rejection, when we found the outlier, we replace it with mean values. And for random oversampling, we found that the data set is bit imbalance. So we use random oversampling to balance the data set. And here the data splitting. For data splitting, we use 80. We keep 80% in training data set and 20% in testing sets. And we deploy total 5 machine learning model. Those are gradient boosting classifier, decision tree classifier, random forest classifier, cat boost classifier, and extra T classifier. Here the evaluation matrix, we evaluate our model based on those evaluation matrix. Those are accuracy, precision, recall, F, and F1 score. Here, the results of our from our model, we can find that those are 4 model and the corresponding evaluation matrix of each model, and it's noted that the extra T classifier perform better. It is 100% accuracy, precision, recall, and F1 score. Here the confusion matrix of the corresponding model. And this is our explainable AI shape values for X-static classifier. We choose X-static classifier. Actually, we propose X-static classifier because of its performance of our various metrics. So we can see that the red lines are representing class 0. There is absence of epileptic seizure, abnormal condition, and the blue colors are representing the class 1. And that's mean in the case of epileptic seizure. And on the y-axis, it is showing the corresponding feature value. So here the conclusion and our future works. We can conclude our work as that we improve the data quality and balance class representation throughout various pre-processing technique, and we developed a seizure prediction system using multiple classification model. We also evaluate the performance of various classification model for seizure prediction based on different evaluation metrics, and we implement the explainable AI to interpret the decision making process of the seizure prediction model. And in the future aspect of our work is we will the model tuning, and in this research we didn't tune our hyperparameter of this model, and for future study we can check the we can check by changing the hyperparameter of different model. And the stacking and weighted ensemble, combining multiple model for enhanced accuracy and performance. Incorporating deep learning, and we also can incorporate deep learning like CNN and LSTM. It is a hybrid classifier model to check whether the perform improved or not. And the corresponding references. And thank you.